Hi guys, it is week 7 that we are looking at, and the 3 lessons we're going over this week are 97 for one day and then 98, 99. So those 3 lessons will get us covered for the week. So lesson 97, you can go and flip over. This is on page 503. We're looking at transversals. So what is a transversal? I'm glad you asked. A line that intersects 2 or more lines is a transversal. So we have 2 lines right here. And the transversal is the blue line right here that is cutting these 2 lines. So it's intersecting more than one line, so it's a transversal. Now, what happens is if we have 2 parallel lines that's cut by a transversal, then we have a whole bunch of different properties and different rules we can apply to come up with it. So when we're looking at this, so angles 3, 4, 5, and 6, we call those interior angles because they're on the inside of the parallel lines. 1, 2, 8, and 7, we call those exterior angles. And then off of here we have supplementary angles, like 1 and 2 have to add up to 180 because it's a straight line. 1 and 4 have to add up. We have vertical angles like 1 and 3, 2 and 4, which we've talked about intersecting lines and vertical angles before. We have corresponding angles. We have alternate exterior. So 1 and 7 are alternate exterior because they're on the opposite side of the transversal and they're exterior outside the parallel lines. Alternate interior like 3 and 5 or 4 and 6 because they're on the opposite side of the transversal and inside the parallel lines. And then what we can do off of that is we can really find any of our angles that we're missing. So even though we have 8 angles formed right here, we only need to be given 1 in order to find the others. So I'll do my best to draw parallel lines. So it's cut by a transversal. We have angle 1, 2, 3, 4, 5, 6, 7, 8. And the order of their number doesn't really matter. So let's say, okay, we're given one of these. We're given angle 1. And it's 100 degrees. It's a little bit more than 90 right here. So this angle is 100 degrees. Now, that's all we need to find all the other angles pretty easily. So this is a vertical angle, so I know that's 100. This has to be 100. I know angle 2 is supplementary because it's got to add up to 180, so this one's got to be 80 degrees. Then these are vertical angles, or this forms a straight line going this way as well, so this also has to be supplementary. And then I can also use this angle and now all these other ones to help me fill in down here. So corresponding, this one from the intersection is up and to the right. 5 is up and to the right, so it also has to be 100 degrees. Okay, alternate exterior, well, that would be angle 7, so that also has to be 100 degrees. Okay, and then corresponding with 4 is 8, because that's from the intersection, it's right and right, so down and right. Okay, and then alternate interior, 4 and 6 are alternate interior angles, so it also has to be 80. Okay, so you notice I have 100, 100, 100, 100, and I have 80, 80, 80, 80. So all of our acute angles less than 90 all equal 80 degrees. In this example, all of my obtuse equal 100. And it's that same principle for anytime we have parallel lines cut by a transversal. If you find one acute angle, you know all the acute angles. You find one obtuse angle, you know all of the obtuse angles. The only instance where they wouldn't be acute or obtuse is if a transversal cut it and they were all 90 degrees. Well, if this is 90, this is 90, this is 90, this is 90, meaning this is 90, 90, 90, 90. So they're obviously not acute or obtuse because they're all right angles. So if they're parallel and they're cut perpendicularly, that's even easier because now we're not finding two different angles and applying them. We know all 8 angles are 90 degrees. So that's the only example where it's not going to be acute and obtuse, is if they're all 90 degrees. So again, these terms, alternate interior, alternate exterior, corresponding, just make sure you're kind of aware of that. But really, all of the acute angles are going to be equal and all of the obtuse angles are going to be equal. That's going to save us a lot of time. So if we know A is 115, I know C, E, and G are all 115 right off the bat without doing any calculations. A and B I know have to add up to 180, so I can do 180 minus 115, which means B is 65, which means D, F, and H are all 65 because those are all my acute angles. Now we can name B and F correspond, B and H are alternate exterior, A and G are alternate exterior, D and F are alternate interior, C and E are alternate interior. So we can name all the rules, which kind of help, but the more important thing is being able to figure out all the different angle measurements. Okay. So 115 and 65. We'll do this practice set together. Okay, so lesson 98, we're looking at the sum of angle measurements of triangles and quadrilaterals. So if we have an exterior angle and an interior angle, okay, those add up to 180 degrees. So I'm looking at this. Angle 2 is inside the parallelogram, so that's an interior angle. If it forms a straight line out here, well then the exterior angle, which is formed right here, angle 1, those have to add up to 180 degrees. Again, a straight line is 180 degrees, so we can use that to find our exterior angles. Now, if we have a triangle, okay, angle 1, angle 2, angle 3 for exterior, they always add up to 360 degrees. So let's say it's a, let's look at, again, simple examples always kind of help make sense of it. Let's say it's an equilateral triangle. This is 60 degrees, and 60 degrees. Okay, and then this is coming out. Okay, there's my exterior angle, and exterior angle. Well, 60 plus 120 have to form 180 degrees. So same thing here, same thing here. Well, 120 times 3 is 360 degrees. Quadrilateral, same thing. Well, the sums, again, let's just use a simple example. Quadrilateral, let's say it's a rectangle. So this is 90 degrees. That's got to be 90 degrees. 90 degrees, 90 degrees. Hold on. This angle is 90 degrees, 90 degrees, 90 degrees, 90 degrees. So 90 times 4 is 360 degrees, just like we had with the triangle. Even though it's 4 sides and 4 angles, still the exterior angles add up to 360 degrees. So if Elizabeth makes 3 turns around the park, then each turn is 120 degrees if she's getting back to where she started. If there's 4 turns, 5 turns, we know that a full revolution is going to equal 360 degrees. So we can use that to apply what the angle measurements of each turn is. So the sum of interior angles of a triangle is 180 degrees. If you didn't know that, now you do. It's something you'll use throughout all of your mathematical career. So it doesn't matter the measurements of angle 1, 2, or 3 necessarily. We just know that they always have to add up to 180 degrees. Because if they're greater than that, let's say, well, we have a triangle where this is 90 degrees, this is 90 degrees. Well, these sides are never going to be pointing at each other. They're going to be parallel, so they're never going to meet at that third vertex. So we're not going to have a triangle. Interior angles of a quadrilateral. So 4, we have 360 degrees, just like or even parallelograms. So we can use that to find missing angles. I know if A equals what? Because B and C equals 60 and 70. Well, we can do 180 minus 60 minus 70. We know they have to add up to 180. That's the total minus 60 and 70 that we know. That third angle has to be 50 degrees. Quadrilateral, again, 80, 80, 110, and what? Well, 360. It's got to add up to 360 minus 80 minus 80 minus 110. And that fourth angle has to be 90 degrees. And that doesn't really look like it's 90 degrees, but at least to me it doesn't, but it would have to be mathematically. So even if it's not drawn to scale or it doesn't look like it is, we know that they always add up to 360. Right, so we'll go over that practice set together, get more practice with that. And then the last lesson for this week is fraction, decimal, percent equivalence. And this is something you've done these throughout the entire year, even if you don't realize it. We've been working on how to work from fractions to decimals, decimals to fractions, fractions to percents, percents to decimal. So you'll see a lot of these types of tables on future tests where you're given one and you have to find the other two. So let's just let's see if we can come up with all right, so let's say we're given 5, we're given 3%, and given 1/3. Okay, so let's just start with the top row. We're given the decimal, okay, fraction. Okay, I know this is 5/10, so I can do 5/10, but then I want to reduce that, so it reduces down to 1/2. Decimal to percents and percents to decimal, in my opinion, are the easiest because we remember converting a decimal to a percent, we're multiplying by 100. We don't even have to do the calculation. If you remember, we move it 2 places to the right, and we can just remember that rule, and we don't even really have to do any calculations. We just move the decimal 2 places to the right. That's my percent. Or if we're given a percent, like down here, I know 23%, so I move the decimal. I'm dividing by 100, 2 zeros, so I'm moving the decimal 2 places to the left. So these back and forth, I think, are very easy. If you don't feel comfortable with those, you'll get very, very comfortable with it. It'll almost become automatic where you don't even have to think about it. So 0.23. Let's go back up here. So 1/3 is my fraction. 1 divided by 3 gives me 3 repeating infinitely. So as a decimal, I 0.3, put that bar above it so we know it's repeating forever. 1/3 is a percent, or 0.3. And we're dividing by or multiplying by 100, so we would do 1/3 times 100 over 1, which gives me 100 divided by 3. So 3 goes into 133 times, which is 99. So I have 1 left over. So 33 1/3%. Or if you want to think of it as 3 continuing on forever, and you move the decimal 2 places to the right, and you want to do it as 33 and 0.3 repeating forever percent. Since these two are the exact same thing, I'll take either way. The book and the test usually wants it written like this, but I'll take it either form. And then back down here, 23%, 0.23 is a decimal. Well, this is 23 hundredths, so we can write it as that, and then no common factors, so that's actually as far as we can go. So we're done. All right, and then we can go back and do this one example, but I think the one we did probably is a little bit more difficult than the one they did. But again, just remember percent is per 100. You can always write that as a fraction and then reduce it. Decimals to percents, move it 2 to the right, percent to decimal, 2 to the left. And then fractions, we know we can write it as 8/10 or 20 over 100 and then reduce it. And we'll do that, practice that table together. All right, so that is it for this week. Good job. We'll see you in class.